Robert, welcome back. It is part two. Let's get caught up. Tell the people who you are.
Hi, folks. My name is Robert. I am currently at X.com helping them rebuild the website. It's extremely excited. I just started. Actually, as of the time of this recording, I haven't started yet, so I have no concrete details on what I'll be doing, but I am extremely excited to uh, have the opportunity to work on such a massive and popular website. And yeah, hopefully we'll be able to ship some awesome new features. It gets faster, more reliable, whatever you want, all of the above. So fingers crossed. That's what's in my future.
I'll make sure to put your links, your social links in the in the description too, so folks can tweet or post their feature requests to you. Well, thanks for being on the show. It's really awesome. Last time we talked a lot about Isograph, and I know you have big plans for that, and you were teasing a bit at what those might be. So, um, tell us what's next for Isograph users.
Cool. Yeah. So a quick recap, Isograph is a framework for building data-driven apps where essentially the fundamental unit of composition is a function from some data to some sort of value. And that value could be a component in the React sense. That's sort of the most common way to do this. So you might imagine, and these this data includes other the results of other functions. So for example, you might have a user avatar that selects the full name, and that full name is itself a function from first and last name. Okay, so you build this sort of tree um, that starts at the root, maybe the home page, and that will include the header, which will include the user avatar, which will include the full name. Um, there's a compiler that will scan all of this and generate all of the files that need to exist in order to make this happen. The query that will fetch all the data for the given page, and so on and so forth. Um, Several things that I want to accomplish with Isograph. One is that we want to allow you to move arbitrary chunks of that computation into the server. So you might, for example, know that you're on a page or on an app or whatever where neither the first and last name ever changes. So there's no reason to ship a function that concatenates the two and then concatenate it. Instead, you can just move that computation transparently to the server. And from the user avatar's perspective, well, it just selects the full name and it just receives a string, which is the concatenation. And from its perspective, it doesn't know or care whether the execution happened on the client or whether it happened on the server. So the first thing one of the things that I want to be able to do is to be able to move arbitrary chunks of computation from this graph to your server. Now, one thing you might have noticed in this is that um, a GraphQL resolver, full name, that's a pretty reasonable thing to have for a GraphQL resolver. And that's exactly right. Like GraphQL resolvers are these things, except they only run on the server. So in one way, you can think of Isograph as allowing you to take these resolvers and execute them on the front end transparently, or I guess depending on needs or what have you. Okay, that's one thing. Another thing that I want to do with Isograph is that it's a way to build apps that are data driven. It currently generates GraphQL queries, but that's an implementation detail. So I want to, in the version 2 rewrite that I'm actively agentically coding at this moment in time, um, I want to essentially from day one have a clear seam where what we actually generate, what language we generate, and so on and so forth is uh, is plug and play. So you'll be able to generate GraphQL, you'll be able to generate um, GraphQL with persisted documents, you'll be able to generate SQL or gRPC or custom arbitrary code, whatever you want. It's up to you. And so that's nice because I think that GraphQL has a lot of benefits, but also sometimes it doesn't make sense because you don't have a GraphQL server, but instead you just have a REST endpoint or something like that. Well, we could just
Hmm.
generate the code that goes into that REST endpoint, or what have you, and it could work with your bespoke system even if you don't have a GraphQL server.
That's
Um,
so interesting. I mean, like, GraphQL batteries included, right? Without
yeah,
GraphQL.
exactly. I mean, it's just the lessons of GraphQL, but without over-indexing on the protocol itself. Because like I think the most compelling thing about GraphQL is that you can have fragment-like composition, which is to say you can have a subcomponent and its dependencies in the same file or declared locally. And as a result, you don't have to reason about the entire app. You can just reason about some subsection, modify it independently, and know that you're still able to maintain certain guarantees, like the right data is fetched for the given page, and we don't overfetch, we don't underfetch. Um, but none of what I just said really specifically requires fragments or GraphQL, and you could just have it just as easily with some other representation, which is sort of what Isograph attempts to give you. Okay, so execute things on the server, arbitrary network protocol. Also, I want to essentially write the core of Isograph, which is currently written in TypeScript. I mean, sort of the runtime. It's currently written in TypeScript in Rust and compile it to WebAssembly, and probably also figure out how to get that to work on iOS and Android. Um, and but basically, you can imagine that the core thing that Isograph does on the front end um, is two things. One is the compiler that generates the queries or what have you, generates
Mm.
something. And two is a runtime that says, given this data in some sort of store, recalculate this function, figure out what's downstream of that, and maybe do something, such as re-render a component. That is all independent of JavaScript. That is, I mean, that makes sense in Android. That makes sense in iOS. That makes sense outside of React.
Yeah, no
So
matter
essentially, I
what. I
want,
mean, if anything, GraphQL gives you a really compelling bridge over a bunch of platforms, right? Like it,
yeah,
no matter what, like the idea of having your data co-located with your components, like all of the major platforms have component libraries now. So this seems like a natural next step, doesn't it?
yeah, I think so. And yeah, and if you can move stuff to the server, well, then you also have the ability to, let's say, this full name field, maybe it's defined in JavaScript. Okay, you can execute it on the client on a JavaScript app, but just as easily from your iOS app, well, you can't execute it on the client, but it's just a string and it knows how to, well, I mean, knows how to deal with
Impressive.
strings, so it can get the result of it. Um, Now, certainly for full name, you probably want a version for every language because they're, it's not that complicated, right? And
Fair.
but regardless, the point still stands. You want to be able to use stuff written in other languages as long as it's sort of executed upstream or something else knows how to execute it. Um, Actually, upstream is a little bit too specific. You might imagine that if you're going to execute something that's written in JavaScript, well, then either it executes upstream or maybe you just have some sort of like local VM that knows how to execute JavaScript. And so it has to go through that on your iOS app. And that's probably not as unreasonable as it sounds. Like React
It's not.
Native, yeah, right? Like JavaScript exists on iOS and Android, right? Like it's
Yeah.
reasonable to do that.
We use
Um,
GraphQL JS and Apollo iOS
mhm.
for certain parts of functionality. I mean, it's it's there.
Yeah. Um,
Fascinating. Oh, wait, well, and I imagine now, like when you're talking about this sort of like cross-platform development, developing for platforms that, might not be immediately familiar with, but obviously Rust and tooling in the tooling is. I'm curious, like I know your workflow has transformed a lot with agentic coding, for example. So you could kind of walk us through that and how it's kind of affecting your development style and how you might tackle a problem like this.
yeah. I think there's two categories of agentic work for programming.
Hmm,
Um, One is creating new code, and another is doing repeated tasks. So on the repeated tasks side, which is not what I'm doing with the Isograph rewrite, but it's actually what I was doing a lot at Pinterest. While I was at Pinterest, we have hundreds of engineers on the website, and over the last 3 months, I shipped 7% of the PRs on our web app. And that's like I could have shipped more. It absolutely could have shipped more. I wasn't actively using this sort of workflow the whole time. And if you are a single person that ships that much, right, like other stuff becomes the bottleneck. And I could have ramped up the agentic coding. I guess the term is software factory nowadays. Um, I could have ramped up the software factory more, but of course, other stuff, namely CI, will find a way to be a blocker in most companies. Okay, so um, all I'm saying is I could have shipped more than 7%. Anyway, so the point is, what did I do? I think I when I injured my hand, which was earlier this year, I slipped and fell on my wrist, and therefore decided that this is um, a moment at which I will start to agentically code everything because, it's time.
Sure.
Um, what did I do? I decided to build the thing that everybody wants to build, which is something some agent identifies refactors and then other agents implement those refactors. And it's sort of this thing. Okay. Early attempts included just doing it with words and so on and so forth. And it was just like bananas. It was really hard to get the agents to like actually commit the changes they made and what have you. And I was missing a lot of primitives. I wasn't using work trees and what have you. So
Mm.
maybe I could have done it without the entire infrastructure that I'm about to describe. But I realized what I was building was essentially a workflow engine. Okay, what's a good way to represent a workflow? Maybe JSON. Okay, so I had this JSON-like thing, and that actually improved the reliability, but the developer experience was not great. I didn't think it was that bad because ultimately you just talk to an agent and have it do the JSON, but it was still annoying to look at it and sort of reason about it. Okay, so then JSON, it's a pretty small hop to a TypeScript builder syntax. And a TypeScript builder syntax, well, essentially, what are we doing? We're describing a workflow. The front end is in TypeScript. So it's essentially an SDL that is SDL the right word? I don't think that's right. DSL, the DSL.
Yes. Ah, yeah.
Uh, yeah, because earlier we were saying SDL for GraphQL,
Yeah.
but I mean DSL. The DSL in TypeScript that essentially defines a programming language. So you might imagine that like something like effect is kind of the same thing. So I wrote this thing. It's called Barnum, and it's essentially a programming language which you use by writing, which you do by writing TypeScript. And on the TypeScript side, we generate an AST that describes the work that needs to be done. And that TypeScript never actually, the data doesn't flow through that TypeScript. It instead, we serialize that AST, we send it to another process. That process is written in Rust. And there is essentially a virtual machine that executes that AST um, on the Rust side, and it will shell out to the TypeScript sort of handlers for all the leaf work that needs to be done. Um, and one thing that's cool is
Can
that
you give me an
every
example like of a task that would be
yes,
and how it
yeah,
might be represented? Give me a trivial task and how it might, because I that boggles my mind a bit. I'm really curious.
yeah, absolutely. So babysitting your PRs.
Right.
You might imagine that you have essentially a loop where, okay, we look at all the open PRs, maybe we filter the ones that target main, and then you see what's wrong with it. Can it land? If you can land it, you land it. If you can't, then you fix it, right? Okay.
Mm.
So the you fix it part requires an LLM for the most part, right? Maybe there's not an automated way to fix some broken unit test. So what you want to do at that point in time, so that requires using an LLM. But most of the rest of that work is something that is deterministic, like list all the PRs, download them, maybe rebase them up to 3 times to just see if that fixes it, because it might be ephemeral. Land it, whatever, run lint. If lint is broken and it's fixable, then just do that and push a new version. Okay, so 90% of this work is deterministic, but there is some non-deterministic agentic work that needs to be done in this workflow. You could specify that using English, but one, like that's going to be like English is a bad language. Well, human language is bad for this because you can't precisely refer to things if you're actually if like the verbosity that you would have to have in your instructions to make sure that they're correct is mind-boggling. It's annoying to read that kind of precise manual code. I mean, not code, but English. And you can't really, there's no way to unit test it. And so you don't even know, you don't have a
Mm.
guarantee that it works correctly. Instead, you're just going to find out at some point in time that it happens to be broken in some edge case. Okay. But you can't just make a program because it needs to execute some sort of, it needs to execute well, it needs to invoke an LLM at some point in time. So the program needs to be able to invoke an LLM. So what Barnum is essentially
And
a
is that a reference to a circus by any chance?
yes, it is. It is.
Okay.
Yeah. I was trying to come up with clever names. I'm very bad at
It is
coming up with
clever.
clever names.
I like
And
it.
it's a ringmaster for your agents because a very early version of it was like the idea was that you would constrain what your agents are doing and therefore like get more reliability out of it. But I haven't reconsidered the name. Anyway, so essentially a programming language where it becomes really easy to invoke LLMs from it. Now, there's another version of this. You might have heard of Claude workflows, right?
Right.
Workflows are essentially you write some JavaScript and then you execute that JavaScript, and that can you can invoke an LLM from there fairly easily. On a high level, that's kind of what Barnum is. But it's not the same because of, well, they made like interesting technical decisions that I don't think are work well for most of the things that you do. For example, rebasing your PRs, or babysitting your PRs. Okay, so you're just gonna do that for like 2 days straight or whatever. You're just gonna keep this running, and then maybe it crashes and you want to like rerun it, or something like that. With and let's say you have a pause in there, like you check the open PRs and you wait 10 seconds and you check them again and whatever, and you only process the new ones. Okay. That's a reasonable way to write this app. Um, with something like workflows, when you crash and rerun, it's going to reinvoke everything, and everything has to be deterministic. And that means that you're only allowed to access the outside world, specifically by going through an agent, and also by and so that's not good because like one of the things, well, okay, we'll get back to that. But the point is like in order to get back to the current state, you're just reinvoking the thing. And if you have a 10-second
Right.
pause, like you're now you have to like now if it dies after 2 days and you want to get back to the current state, it's still going to take you 2 days to get there, which is like there's a lot of problems that sort of that match this pattern that would be a poor fit for that. And the
Sure.
other technical decision that they made is because everything has to be deterministic. You can't actually read the file system. You have to go through agents to read the file system. Now, agents are sort of known to be token hogs, and especially workflows are known to be token hogs. And that's like a big reason for this. It's like if you are going to list all of the files in your repository, filter them down, and then do something else, well, it doesn't make sense to ask an agent to list like 100,000 files. Like, what if one of those files is like, I mean, it just might get the name wrong
Sure.
somewhere in that list.
Yeah,
Like,
that's a
it's
lot of
weirdly
context for it.
unreliable. Yeah, exactly. Um, and like, okay, then your filter. Okay, so now you at least have to read the files and then marshal them into JSON, and then you filter them and you go through the agent again. It's like just doesn't make sense. Like this is the kind of stuff that you should just be able to do in a program, and that's what
Sure.
Barnum is. And so the reason
So
that
it's
you
like a
need
way to like encode common workflows into something that's repeatable and perhaps
yes,
idempotent and things like that. So,
yes.
ah,
So with Claude workflows, the whole thing, the whole unit is the unit of restartability, resumability, or what have you, replayability. But
yes.
with Barnum, sort of every single little leaf, like the trade-off you make is that every leaf runs in its own process. And of course, there's like some overhead to spinning up a new node process to like maybe add two numbers. Okay, like that's kind of wasteful. But the idea is that we're gate kept, or we're slowed by these long running agentic processes. So for example, it doesn't matter if it adds a couple 100 milliseconds to do this or that, if we spend 5 minutes refactoring a file as part of the workflow.
Yeah.
Um, and because we have forced you to make all of the changes, all of the leaf work in these small self-contained units, well, the whole state of the world is serializable at every point in time and introspectable. So if theoretically I were to implement resuming in Barnum, well, we know the exact state that we were in, and we could just restart from exactly that state. So you could pause and resume with no,
Perfect.
yeah,
That's really cool.
you know.
Well, that's
So
I was not
yeah,
expecting to hear that. That is amazing. We'll definitely drop, or I don't know if it's shareable or not, but if it is, we'll drop the links
yeah, it
in
is. It's
the
all shareable.
description.
Yeah,
So cool. I would love to check that out. Well,
yeah.
I asked this of everybody here who comes on the show. Can you find something on your desk or in arm's reach and talk about it for a sec?
Yes. This is my keyboard here. This
All
is actually
right.
just one half of a Kinesis 360.
It's
So
incredible.
yeah, when I injured my left hand, I mean, now it's fine. But I'm just sticking with this because it's fun. I have a
Uh-huh.
keyboard remapping, custom bespoke keyboard remapping tool that I use to sort of operate my computer entirely with one hand, including a custom keyboard layout and a bajillion different layers and so on and so forth. And it does like really cool contextual stuff. Like I have a way to it knows which agent I want to send. I can like select some text and send it to a specific agent or send a screenshot to a specific agent without
And that's all on the keyboard.
tabbing back. It's
So
all
cool.
controlled via the keyboard. Yeah.
Uh,
Um, or like I have different key bindings for different tabs and different apps and so on and so forth. Um, I haven't like fully taken advantage of the different key bindings for different tabs. But I imagine there's a lot of stuff that I want to do
I think,
with that
there's
functionality.
always an asymptote in the number, in the trajectory of things we can optimize.
Yeah.
So that's incredible. I mean, Robert, thank you for sharing that and um, all of your accumulated wisdom on GraphQL and agentic coding. It's just such a privilege to speak with such an inspired person on a variety of these topics. So we'll definitely put the links in the description for folks to check out. But thanks again. I'm really looking forward to sharing this interview with the audience.
Cool. Well, thanks so much for having me, Jeff. This was a lot of fun. I'm always happy to talk about this kind of stuff. It's, if I wasn't getting paid to program, I still would find a way to do it. So I'm happy to chit chat about it whenever.
I have no doubt about that. And I'm also going to put some links in the description to Robert's GraphQL Conf talks, which are amazing. And we could do an entire other interview on your talk prep process, which is fascinating. So thanks again, Robert. And I can't wait till the next time.
Cool. Bye, y'all.
Catch you later.